And one of these things is around moving from a Power BI centric, that kind of data flow and Power BI model that we saw earlier, to a Fabric centric architecture. Because one of the massive benefits of Fabric is that it makes it a lot easier to build these more robust architectures, right? So instead of doing data sources, Power BI report, here there's a subtle difference where now we're bringing data into the Fabric environment. Okay, Power BI is part of Fabric, but I'm talking about the other stuff in Fabric. You bring it in via a data pipeline or notebook or even a Dataflow Gen 2, storing it somewhere in Fabric, and then using that for your Power BI models, semantic models, Power BI reports. It's a very subtle change, but it enables us to do some very powerful things. I have a whole series about this that you can have a look at as well. So let's look at what this could look like. Obviously, we have lots of different sources normally for our analytics projects. And here, maybe some of you know what I'm kind of drawing here, or at least visualizing. We have different layers, right? And this is what some people might call a medallion architecture. I haven't used the gold, silver, bronze terminology here, just tried to keep it kind of plain language. So we're going to get some data from a source. We're going to clean it, might enrich it, add some new columns, merge it, that sort of thing. Build these reusable analytics models, right? So still kind of in that probably data warehouse, but reusable analytics models. And then from that, any sort of semantic models, right? So if you've got any reports that you need to develop, that's where you're going to do that there. One of the benefits of doing this, so from a robustness point of view, when we add different layers into this thing, by definition, we're basically putting in more barriers, right? Which is good in some ways, but then obviously you need to manage that, right? Good in some ways, because if source 2 suddenly gives us a problem, we've got lots of different layers and we can build in some resilience into that, right? Secondly, another benefit of this kind of approach over and above what we saw previously, so you notice here that I've got consumption options. Now, I think for a lot of people that kind of come up through the Power BI space, the consumption options is just Power BI, right? It's like that's everything. But in fact, there's lots of different ways that we can consume data, right, in an organization. Could be a data science project, could be machine learning project, could be an AI skill, right? That's a brand new feature, relatively new feature that allows you to write plain language questions. Then Fabric is going to convert that into a SQL statement, right? And that's not reading from your semantic model, that's reading from your lakehouse or your warehouse tables. Then you've got good old-fashioned, what I would call SQL-based data analytics, right? So you don't have a Power BI report, you're just writing SQL and solving business questions with SQL. You can also connect to Tableau, right? So one of the benefits of Fabric, for me at least, is that there's many different options in this consumption layer, right? Including the front-end application. So if I wanted to do one of those data journalism articles, it'd be a lot easier now than it used to be, right? So there's a lot of different options. And when you have a lot of different options, it helps if most of your modeling is done in this section here, right? Then you've got all these layers of like orchestration, monitoring, logging, governance, quality, CI/CD. And for me, this kind of analytics engineering core, and maybe this is where my opinions differ from like the DP600 study guide. For me, it's all about building a really tight core in there, right? That you have your governance, you have your quality control, and obviously these things extend into the like consumption layer. But the analytics engineer, for me, focuses on this central bit, specifically nearer this end than this end. Sometimes you hear, okay, what's the difference between a data engineer and an analytics engineer? So for me, well, in some companies, they'll be the same person, in a lot of companies, in fact. But if you're lucky enough to have distinction between both, it will probably be that the data engineer spends a lot more time on this side, creating new connections, especially for connections that don't have an official connector, so like REST API calls, that sort of thing. And also more generally around this orchestration, monitoring, and logging. They're like pretty classic data engineering tools, tasks. Then the analytics engineer is working, they have a lot more kind of business savvy knowledge. Normally they might come from that analyst position, so they understand the business a bit more, and they understand the kind of data models that you might have to build, and they have an appreciation for the data, right? We'll look at that in a bit more detail in a minute. If we go back to that kind of Power BI centric model, I've got a bit of a fag packet sketch, as we call it, over here. And on this graph, what I'm trying to show is on the left-hand side, you have transformations. So the amount of transformations that you're doing and like the amount of business logic that you've got stored, and also your intellectual property, right? Because that is intellectual property. So in a Power BI centric architecture, a lot of that is locked up in your data flows, Gen 1, in your semantic models in Power BI, right? In your DAX calculations, that sort of thing. And you might have heard Roche's maxim, right? Data should be transformed as far upstream as possible and as far downstream as necessary. Now, I think when that was originally written, what that meant was, do a bit less in your DAX and do a bit more in your Power Query engine, right? Well, now for me at least, I haven't spoken to Matt Roche on this topic, but for me, it means moving a lot more of this stuff into Fabric, right? You're always going to need to do some semantic modeling in your semantic model, of course, if you're going to use Power BI. But there's a lot of opportunity to bring some or most of those transformations, that cleaning that you do in a semantic model or in Power Query, further upstream into Fabric. Now, why might you want to do that? A bit more like this, right? Well, as well as that resilience piece that we talked about, you also get some other benefits, right? It's a lot easier to validate stuff in that kind of SQL world, the Python world, because we have a lot of different options available to us. It's also easier to reuse the tables, right? You can very easily reuse like a gold layer data warehouse table. You can connect that to multiple different reports. A bit more difficult to do that if your logic is tied up to a semantic model. Not impossible, but more difficult. Obviously easier to govern and document what you've got, right? And you've got less of your IP wrapped up in what I would call Microsoft E technology. So when I mentioned this last time, there was a bit of a discussion around this. What I mean is that in this green bit, the Fabric bit, you're built on top of Delta technology, Delta Lake. You're writing mostly SQL code or Spark code, and these are very transferable, right? You can move to Databricks if you want. You can move that to Synapse if you want. You can move your SQL over to Snowflake, for example. It opens up a lot of options for you in terms of your data strategy. Now, you might not think about that now because you're just migrating to a new platform, but these are really important factors, right? If all of your IP and your business logic is locked into Power Query and DAX, that's fine. But, if you want to look a bit further forward and open up your options, then it's definitely going to be useful for you to shift some of that, or as much as possible of that, more upstream. And if you're doing this, it opens up all these options in the consumption layer, right? All of that data science stuff, the machine learning stuff, AI skills. If you're bringing all of your IP further upstream, opens up way more options in the consumption layer. So that was a little bit about robust systems. And I could have spoken a lot about that, but we've got 3 more things to talk about. CI/CD, right? So you might have used some of the CI/CD features. Here we're talking about Git integration, deployment pipelines, and also the Fabric REST API, which allows more advanced use cases, basically to automate some of your deployments and things like that. Now, one thing to bear in mind with version control in Fabric is that you're not fully in control. So if you've used any sort of, or you've done any sort of software development and you've used Git version control for code, you make changes to a file, like a script, SQL script, or a Python script, or a JavaScript file, and then you commit that to your Git repository. And then that's what's stored on Git. Easy as that. In Fabric, things work a little bit differently, right? When you make changes to an item in Fabric, it's actually Fabric, or like Microsoft, the technology itself, that writes a representation of that item, of the current configuration of that item, into a kind of text format, right? So your data pipeline, it gets written out as a JSON file that kind of lists out all of the activities and that kind of thing. Your notebook is quite a fairly straightforward one because that is mostly code, right? And then that is the thing that gets written into version control. Why is that important? Because you don't really have control what gets written into version control, right? So you need to understand what Microsoft is doing under the hood there, right? It's quite an important thing to understand. For example, if you have a look at data pipelines, if you do a bit of an investigation, just changing things in the UI and seeing what gets written out into that JSON file, it's quite interesting. So data pipelines are actually quite a good one, right? But still, things like scheduling is not written into your pipeline. There's lots of other things as well. I'll be doing some videos on that in the future. One thing to bear in mind is that CI/CD is currently, pretty much all of it is in preview, as if you've tried it, you would have noticed. On the version control side, the Lakehouse is not really supported at all yet. Dataflow Gen 2, not supported at all. Other items, to more or less degrees, are supported, but you might still have some niggles with these as well. And it's a similar story with deployment pipelines, right? As far as I can tell, just from being a user, the state or the configuration that gets written into version control very closely matches what gets deployed, right? It's almost basically they take the configuration that's on your Git repository and they use that in your deployment. So in the case of a Lakehouse, when you check in a Lakehouse into version control, there's basically nothing, right? So when you deploy it, there's also nothing. So it's just something to be aware of. How do you approach this if you're new to CI/CD, version control, that kind of thing? Well, there's a lot of different approaches, right? And they all have pros and cons. So if you spend a bit of time just at least being exposed to different ones, like search on different blogs or on the Microsoft website as well on documentation, I would say it's useful to get exposed to a few different strategies. It's still kind of a developing field, I would argue. I don't think there's a best practice just yet, and every company is different, okay? So what I would do is just learn something like this, understand the different terminology. So yeah, understand what branches are, understand what a feature branch is, things like pull requests, all these different things, deployment pipelines, just understand what they do and what purpose they serve. But then think about how you can translate that into your company, right? Because some companies, just having version control might be a good step, right? Having your workspace backed up by a Git repository is a good first step, at least. Very much a sliding scale, this stuff. It can go from very, very simple to insanely complex, and different companies have different requirements somewhere along that spectrum. Next, we move on to the modeling piece, right? And earlier I talked about this diagram. I just want to focus on this section here, right? Where the central core bit gets consumed. Because when we talk about data modeling, what do we really mean for analytics engineers? What are the skills you need to be good at that? Well, there's a few different elements, right? And for me, it's about having that deep understanding of what your consumer wants, right? Some people call that domain knowledge. What do they want? And how do they want it? What format do they want it, right? And that varies depending if you have different consumers, right? So your Power BI developer probably wants some sort of facts and dimensions and that kind of thing. And you need to understand more about the business, right? To understand why they want those things and how to structure the data. Your data scientist might want your data already kind of pre-transformed into features that they can just load into models and stuff. AI skill, I think there's probably some really interesting research to be done there around what that should look like, because I'm sure there's data models for AI understanding that might be different from the ones that we currently use today. And a front-end application, if you're doing some website on top of your Fabric stack, they might want your data in just JSON format so they can read it directly into their front ends. So it really depends on the consumer, type of consumer, and what they want and how they want it. So that's one of the key elements for data modeling for analytics engineers, but it's not everything, right? The second point is an understanding of what data you have and what data you can create, right? So you need to be really sure what you've got in your tables and what you can easily build if need be, right? So if the consumer requires something you don't have, you also need the technical knowledge and the ability to create it, right? Or at least know what's possible. And these are kind of like a interesting three-way discussion, right? Normally you're speaking upstream, you're speaking to your consumer about what they want. But then in your back of your mind, you're always thinking, okay, I can do that with this table. I can do that with this table. We've got this view, that kind of thing. So you're kind of marrying these two together. For me, it's a little bit like if you got a job as the Saturday guy in a furniture shop, right? And a client comes in and you're completely new, right? You just started this new job and you've got like 1,000 chairs in this department store. And then a client comes in and they're like, okay, I want a chair that's suitable for my granddad, whatever. And then you as the new shop person, you don't really know anything about any of these chairs because you just started working there, right? You need basically to be a good shop assistant, you need that experience, right? You need to understand what chairs you've got. You need to understand which ones are good for which purpose. You need to understand that all of these chairs, they break sometimes. They have a problem with their legs when you do certain things with them. You also need to know that, oh, we've got this guy down the road, he does modifications on chairs. If you don't know any of that, you can't really have a good conversation with your customer when they walk in, right? And it's similar in the data world. But instead, the consumer here could be any of these. And the chairs is like all of your different objects that you've got somewhere in a data warehouse or a lake house, right? You need to understand what their pros and their cons and really know pretty much every table and sometimes every column inside out. And that can obviously take a while if you've got a very big data estate in your company. But it is so important for analytics engineer to build up that knowledge so that you can be a better kind of communicator, right? So the final point that I wanted to talk about here was around validation, right? And validation for me is so important, right? Because how can we build trust in our data and our reporting and our analytics outputs if you're not validating it, right? It's just guessing other than that. So what could this look like? Well, here we've got the same architecture that we were looking at before, but I've just written out the tables into different sections of a Fabric environment, right? So getting new data, passing it, enriching it, building some sort of analytics models, semantic modeling on top of that. And at each stage, we're writing some stuff into lakehouses or warehouse tables along the way, or semantic models. Now, one of the benefits of doing this is that at each of these steps, we can validate what we're writing, right? We can build in little rule sets that are going to say, okay, at this point in my architecture, the data set should look like this, right? It should have these sort of properties, right? It should have 4 columns, should have 100 rows or whatever, should have these different columns, and it should be this data type, and depending on what your data is. And obviously these are going to change at different points, right? As you maybe do some enriching of the data, these little checks along the way are going to change. So over time, you've got a few different checkpoints, right? Before your client or your user sees that data, you're basically stepping up. You're progressively assuring that data quality, right? So over time, getting higher and higher and higher. As you're going through different checkpoints, you've checked the file structure here, you've checked maybe like the number of rows and the columns, and then here you've done some sort of data modeling, and then you've checked that as well. Here you've done some semantic modeling and you've checked that as well. So by the end, your user can be a lot more confident, and you can be a lot more confident that the data that you're providing is going to be of good enough quality, right? And so this kind of relies on 3 different methods. Again, I've got videos about this on my channel. We talk about schema validation of incoming files, data frame, and table validation kind of in the middle, and then semantic model validation at the end, right? Which is an important last step because that's kind of the last mile, right? If you're using Power BI. And again, I've got quite a few videos on this, so if you want to check out more on that, have a look. So these for me are the 4 probably most important focus areas for effective analytics engineering, for building trust, right? Building robust pipelines that are resilient in the face of change, implementing CI/CD, basically making sure that the new stuff that you deploy doesn't break any of the old stuff and you sufficiently tested that in another environment, and that you've got a record of change of all the changes you make to your analytics code and your models. Then you've got the actual modeling piece, right? Which is so important. Understanding a business problem and modeling it, preferably in a reusable way, so that you're not just focused on this specific use case, but you're kind of making reusable models. And validation, right? Very important last cornerstone for analytics engineering. So just to wrap us off, I've got 8 more random tips, right? So this is all the other stuff that I couldn't fit into the rest of the presentation. Bit of a random selection of things that I think are important. Number 1 is get hands-on, right? Stop watching idiots on YouTube like me talk about Fabric. Really, you only start learning when you open it up, app.fabric.microsoft.com, and you start building stuff. That is really when you start to learn. If you're in this analytics engineering role, you need to learn your company's tables inside out, right? You need to understand, at least for the main tables that your company's using, learn every column, learn how it gets updated, what the little tricks are, what the problems are, where it fails, that kind of thing. Because that is such powerful knowledge once you have that. Learn to love documenting. You should look at documenting as acquiring new knowledge, not as a chore, especially when you're new, right? If you come into a new company, how do you do this learning your tables inside out? and learning how pipelines work, sometimes it can be very complex, right? You turn up at a new place and you think, oh, how on earth am I going to learn how this thing works? It's like 500 lines of code. Well, the answer is to document it, right? You might already have documentation for this thing. You can use that, but I would still argue that it's still important to do your own documentation, right? To help you assimilate that information yourself. Informed pessimism is a bit of a skill, right? So you have to be pessimistic in this sort of game because you're an engineer. That's what they do. You have to always think, how can this fail? In what ways could this pipeline fail, right? I've got this connection to a REST API. Okay, what kind of controls can I build into that to build a bit of resilience? And obviously that comes over with experience, right? Normally it comes from failures, your pipelines break, and then over time, you make them more and more resilient. Which brings me on to this point, right? Be a super responder. So if something breaks, own it, and then develop some sort of rule sets, validation rules, unit tests, that kind of thing, to make sure the same thing doesn't happen again. In doing so, over time, you're gradually building more and more effective systems. Now, I would focus my learning on what I call open or widely used technologies, right? Especially earlier on in your career. And this is one of the key benefits in Fabric, is that a lot of the technology stack is kind of like industry standard, right? Spark, SQL, Python notebooks, Delta Lake, all of these technologies are used across thousands or hundreds of thousands of companies, right? So although you're using a Microsoft product, if you focus your learning on that stuff, the amount of leverage from your time spent learning is very high. Because if you learn SQL data modeling, that is a very widely applicable skill set, right? You could get a job probably working in like a Snowflake environment or like a Postgres environment, slightly different flavor of SQL, but that skill set is a lot more transferable, right? Especially earlier on in your career. You want to keep your options open, in my opinion. Spend some time outside the Microsoft bubble, right? Might be a bit controversial thing to say, but when you're learning to solve data problems with a completely different skill tool set, it forces you to become a problem solver, right? Not just someone who knows the right buttons to push in this specific software or that kind of thing. If you get exposed to completely different stacks or you get the opportunity to do that, I definitely recommend it, right? Because it makes you a more well-rounded data professional, in my view. And then you bring that knowledge back into the Microsoft environment, and it gives you a slightly different perspective on how to solve problems, in my opinion. Final one, always try to fix things at source, right? You want to be trying to implement fixes as far up the data pipelines as possible, right? Now, sometimes that can mean making friends with source system owners or API owners, that kind of thing, right? Because if you can get them to implement changes in their systems, and then you can kind of remove the need to do transformations and wacky like filler jobs in your pipelines, right? It's always better to get the data, to use the data example, get the data formatted in the source system correctly, and then you can just pull it in easy as possible. So those are 8 random tips. Just for a recap, recommend focus on these 4 things. If you get really good at even one of these, you can definitely build a good career in analytics engineering. All 4 of them, and you'd be really, really valuable. Plus, don't forget these 8 random tips. Getting hands-on, know your tables, love documentation, be a little bit pessimistic, super responder, transferable skills, escaping the bubble, fixing things at source. And overall, good luck. these are very exciting times to be working in Fabric. And for me, analytics engineering in particular is, I would argue, probably the most important skill to learn right now, because it basically enables AI and BI, right? If you've used any sort of AI tools, you know the importance of things like validation, right? Very, very important. So it's a very exciting place to be in. Very good skill set to learn. Good luck with it.
Great. Well, thank you. Thank you, Will. And we've got a few questions in chat and many thank yous too. I thought what we would do is close out the meeting, and then we'll stop the recording, and then we'll ask some of those questions. We can leave the recording running, but let's officially close out the meeting. So again, Will, thank you for your presentation. Thanks everyone for attending tonight's meeting. You know about a few of the meetings coming up. We'll keep scheduling them. We'll let you know what is on the horizon. If there are topics that you are interested in, let me know, and we'll see what we can do. And if you're interested in speaking, that is always an option too. So thanks everyone, and have a great evening. And at this point, we'll move right into some of the Q&A. So James posted a question for you, Will, on what's your preferred method or methods of documentation? Do you have some tips that you can share there?
Yeah, absolutely. So there's two real types of documentation, I would argue. There's documenting in a system like Confluence. That's a really good tool if you've used that, but it's kind of like outside of your environment. The other option, if you want to keep your documentation closer to your data, is to use things like Great Expectations, which is a data validation framework that has inbuilt functionality for setting documentation. dbt is another example there. So some of these more modern tools, they basically build documentation features into it, right? So when you're building a data model, you can document it in like a markdown file, but it's attached to the actual data model. So it's a lot closer to your data, right? Sometimes when you have documentation like written in Confluence or something, it's great, it's better than nothing. But to have it like right there where your team's working is definitely a benefit. So there's two different options, but yeah.
Okay, great. And I should mention, we'll get onto some other questions, but Will has posted URLs for the sites that he talked about for getting additional information, and looks really valuable. I know it is because we've been hearing about it throughout the industry. He's become quite popular. I'm curious how much is the subscription for your paid version?
Yeah, so these are the different things I have. These bottom two are free, so you can join that one, school.com/Microsoft-Fabric. This one's a new one I've just released, Fabric Dojo. So it's currently $29 a month for that. It's going up at the end of the month. So if you want to sign up for that, yeah, you get tutorials, basically trying to get people hands-on, right? With support there as well. So we do weekly calls, mini projects, that sort of thing. So if you're looking to get hands-on with Fabric, yeah, I recommend that.
Okay, great. And I had a question that and I know that there's a huge amount of variation, but you listed out the as you went through the pipelines, CI/CD, modeling, and validation. I'm curious as to whether you have any kind of rule of thumb about what percentages of a project fall into each category, or if there's any one or two that are usually much smaller or much larger. Any thoughts on that?
Yeah, absolutely. Yeah, good question. So things like CI/CD normally are defined like at a company level. Normally you'd have like a strategy for how you manage CI/CD, right? So as an analytics engineer, unless you're the first person to kind of implement CI/CD, normally it's just understanding the structure that's in place and conforming to it, right? Now, if you have to be the person that comes into a new company and sets this up for the first time, you have to know a bit more about it, right? Because you have to not just be aware of how things work, but understand the pros and cons.
Mm-hmm.
So yeah, on a typical analytics project, you kind of set it up to begin with, CI/CD. Same with robust pipelines, right? So that's going to be, for me, a big focus for an analytics engineer, at least in the early days when you're setting up an architecture. So once you've built those pipelines, you've built out a bit of a structure for your project, then the focus becomes, in that aspect, just like maintaining, logging, checking that pipelines have run, that kind of thing. So it's quite a small element of your day, I would say 10% once you've got it built. Most of your time should be built or worrying about modeling and validation, in my opinion. So understanding, building new assets, like data assets, and then validating them, and always building more and more validation rules on top of them. So yeah, modeling and validation, I'd say, are like the bread and butter for an analytics engineer.
Got it.
CI/CD at the
and
start.
Obviously those vary tremendously depending on the data. But okay, great.
Exactly.
Thank you. Anybody who wants to ask questions, you can come off mute. You're not automatically muted, so you can come off mute and you can ask any questions you want of Will. There are many comments in the chat, mainly thank yous. This is excellent. Gonzalo, very good presentation, shows good engineering. I really like it. Thank you. Likewise, David and Dan. A little longer message from Chrissy that you can see there, Will. Bob, John, Teresa, Colin's pointing out that, I mean, Colin runs a team of consultants who do database and application development work, and this is very applicable to what he does too, of course.
Yeah, it's a good point. That last one from Colin. So I tried to, although I talk mainly about Fabric, like these are general principles, right, for analytics engineering. Yep. So like, all of those 4 things are not like Fabric features. They're possible in Fabric, but for me, analytics engineering as a discipline, it's like how to apply those best practices or those disciplines in a Fabric environment. So good that you picked up on that. Cheers, Colin.
I have a question.
Great. Sure,
go for it.
I was surprised listening to your presentation. That was going through my mind was how useful it would be presenting this to management, like literally the talk that you gave, where engineering and related to trust, and like the whole thing was very, I think, plain spoken, intelligible, because what I find is I go in an organization and I have to explain to them why these costs are valuable. And so I think it was actually very digestible, like unchanged, to take your presentation that's going to be posted and show it to a manager as why they should invest in engineering processes generally. What do you think about my take on that? And not, don't get me wrong, like this is great from my point of view, design and build, but also I need to get buy-in, and I'm thinking this could help.
Yeah, no, it's a really great point, because I think it's sometimes quite difficult to communicate the benefits of this to like senior leaders in organizations, right? They see it as a cost rather than a potential saving, right? When you're building like Power BI reports, there's a tangible thing there, right? It's much more tangible. We built this CEO exec dashboard and they can look at it, right? With analytics engineering, it's a bit more like work behind the scenes. Probably what I would suggest is just to tell stories, right? I'm sure everyone's got stories of when they've looked at dashboards or they've looked at some like data science project and the data's wrong and it's caused some sort of problems in the business. Just to focus in on those stories and those events, and try to tell the story that, you know, if we want to truly build sort of trust in the stuff that we deliver, you need to add some sort of engineering discipline along the way. Yeah, but it's a difficult conversation to have. I agree.
You know, we the trust part of this, we run into it all the time. I mean, I'm sure everybody on this call and Power BI makes it very easy to show something that looks great, and then
Exactly.
they find out the numbers are wrong, or you
Yeah.
get something that becomes mission critical, and then something breaks or something happens upstream, and suddenly it's not working the way it always was. And so even you know, creating the trust, it requires effort to maintain it, because things break, and then that trust becomes very fragile. We run into it with clients all the time, and
Exactly. Yeah.
we're going to definitely share this recording with other people on our team who couldn't make it for this particular meeting.
Yeah. And the good news is it's now easier than ever, right? Because it used to be a bit more challenging to build this like engineering rigor into your like processing pipelines. You know, before we had like stuff in Azure, Synapse, things like that, it was possible, but now everything's kind of under one roof. So it just makes it a lot more accessible. And I think a lot more companies are going to be open to trying and building these sorts of features. At least I hope.
So Anvesh is asking, first of all, he's thanking you. He's asking if you have any examples or tutorials that show various data quality checks that at every layer that you mentioned. Do you have specific tutorials or examples in the material you've created that would?
Yeah, so there's two videos I've got on that topic. This one has that kind of end-to-end approach with the different layers, and there's also some demos there and like sample code. And then in this, so that's kind of like the first port of call. And then in here, we've got a whole section around data quality. It's like in the whole section on code quality and data quality and data validation. So yeah, it's like a core part of this offering here.
Great.